Welcome to all. Now we will concentrate our study to a particular type of algebraic expressions, polynomial. Polynomials are algebraic expression which contains one or more term, and each term consists of a constant multiplied by a variable raised to a non-negative integral power. That is 3x plus 2. This is a polynomial. How many terms are there? 2 terms. Suppose x square plus 3x minus 2. This is a polynomial. An algebraic expressions which contains more than one term, and each term consists of either a variable or a constant multiplied by a variable or a constant term. Okay. Then all algebraic expressions are not polynomial. For example, suppose consider x plus 1 by x. This is an algebraic expression, but it is not a polynomial. Why? Yes. Exponent of this variable x here is 1. But what is the power of x here? Yes, x raised to minus 1. So we can write it as x plus x raised to minus 1. So this is a negative number, not a whole number. So this is not a polynomial. Then x raised to 2 by 3 plus 2x minus 3. Whether this is a polynomial? No, this is not a polynomial. Why? The power of the x here, it is a fraction. It is not a whole number. So this is not a polynomial. Okay. So polynomials are mathematical expressions in which the power of the variable should be whole number. So all polynomials are mathematical expressions, but all mathematical expressions are not polynomial. So, but then, what are the applications of polynomials? Why we study this on polynomial here? I have already told you that you have to give more importance to these sections, polynomial. Why? Yes, due to its importance. The career professionals, one who use polynomials on daily basis, are engineers. They use polynomials to design cars, to design building, to design road. All these things they use polynomials. When you go to this one engineering field, then you can understand that. So what's the importance of polynomials there. Then the polynomial is an effective tool to predict and describe the traffic lights you have seen in traffic light. The design of the light you have seen, the pattern of the light you have seen in the traffic light. Polynomials are used as an effective tool to design that thing. Economists use the polynomials to predict the economical growth. Medical researchers use polynomials to study this one bacterial colonies and some other things. Even the ordinary people who do not know anything about mathematics use polynomials in their brain. Suppose one want to go to a shop to purchase something, then they use polynomials. That is, for examples, what is the cost of one book, then how many books he can purchase with the limited amount of money in his hand. For that things, he uses polynomials in his brain. So polynomial has a lot of applications. That is, polynomial is the backbone of mathematics. Okay. Polynomials are algebraic expressions. So like algebraic expressions, polynomials are classified based on the number of terms it has. Polynomial with only one term are called, yes, monomial. Polynomial with one term. That is monomial. Monomial. Example, 3x, 2, the constant term, 2, 4x square, etc. Then polynomial with the 2 term, yes, binomial, polynomial with the 2 term. With the 2 term, binomial. Example, square plus 1, x square minus 1, etc. Only 2 terms should be there. Then polynomial with 3 terms, trinomial 3 terms. Trinomial. Example, yes, x square plus 2x minus 1. Okay. The highest power of the variable in a polynomial is called degree of the polynomial. Consider a polynomial px. X raised to 6 plus 1. What's the highest power variable here? 6. So degree of the polynomial is 6. Then t raised to 3 minus 1. What's the highest power? Yes, 3. So degree of the polynomial is 3. What's the highest power of the variable here? Yes, 3. So degree of the polynomial is 3. Yes, this is a constant. Degree, exactly right, 0. That is 2 into x raised to 0. That is equal to 2. So degree of the polynomial is 0. Degree of a constant polynomial, this is called constant polynomial, is 0. Never forget that thing. Then we can classify polynomial based on the degree they have. There are some specific names attributed to polynomial based on the degree of the variables it contains. First, polynomial with the degree 1. That type of polynomials are called linear polynomials. Never forget these terms. Linear polynomials. What is this? Degree with 1. 1. Example. Exactly right. How can we name it? Yes, okay, px. Oh, 3x. These are our linear polynomials. Okay, 3x, one term. Then, say one example that a linear polynomial have 3 terms. 3 terms. Say one example. 3y, okay, plus y minus 3, minus 3. What is the result of this arithmetic operation? 4y. 4y minus 3. This is the expression. How many terms? 2 terms. So it is not possible to write 3 terms in a linear polynomial. Linear polynomial must have maximum 2 terms. Then polynomial with degree 2. It is quadratic polynomial. That type of polynomial is called quadratic polynomial. Degree with 2. Example. Say one example. Yes, x square plus 1. Then another example. Y square plus 2y minus 1. Yes. Try to write another example with 4 terms. T square 2t minus t. Then 2t minus t is t. 2. No, it is not possible. Maximum 3 terms. So for quadratic polynomial must have maximum 3 terms. Not forget that things. T square, this is also a quadratic polynomial with 1 term. It is a monomial also. Then polynomial with degree 3. This is cubic polynomial. That polynomial is called cubic polynomial. Cubic polynomial. Degree with 3. Say one example. Yes, t cube plus 2t square plus 4t minus or plus 1. Okay. How can we write it as gt? or pt, whatever it may be. Maximum 4 terms, minimum 1 term. We will write the general form of polynomial with different degrees. Polynomial with 1 degree, that is linear polynomial. The general form is ax plus b. Condition is this one, a should not be equal to 0. If a is equal to 0, what will happen? A polynomial will become b, constant polynomial. What is its degree? 0. Understand? That is 2x plus 1. This is a linear polynomial. And the condition is coefficient of x should not be 0. That is the return. Coefficient of x should not be 0. If this coefficient will become 0, what will be the polynomial? It will become 1. It is a constant polynomial. What is its degree? 0. So let's write. So this is the general form. Very simple. Then polynomial with the degree 2. General form? Yes, ax square plus bx plus c. Condition. Yes, a is not equal to 0. If a becomes 0, that is coefficient of x square is 0, what's the polynomial then? Bx plus c. It is a linear polynomial. Then polynomial with the degree 3, what is its general form? Instead of x, we can write it as y. Ay square, ay cube plus by square plus cy plus d. Condition. A is not equal to 0. These are the general form of polynomial with different degrees. General form of polynomial. We will look how to write the general form of a polynomial. A n x raised to n plus then a n minus 1 x raised to n minus 1 plus etc. A 2 x square plus a x plus a 0 a1. This is the general form. What does it mean? A n? Nth term? No. A n represents coefficient of the variable with the power n. That's the meaning. Coefficient of the variable with the power n. That is a n. A n is a constant. I have already told you that the coefficient should be come first. What does this? Yes, exactly. Coefficient of variable with the power n minus 1 is a n minus 1. A0, coefficient of the variable with the power 0. So, a n minus 1, etc. a0 are constants. If a n is equal to a n minus 1 is equal to etc. is equal to a0, all these are 0. A n is equal to a n minus 1 is equal to etc. a0 is equal to 0. That polynomial is called a zero polynomial. It has very, very importance in algebra that you will study in higher classes. Zero polynomial is represented by 0. What is its degree? What is the degree of a constant polynomial? Yes, 0. 0 is the degree of a constant polynomial. Constant polynomial is 3. One example. Or 4. What is its degree? X raised to 0. That is 0. What is the degree of a 0 polynomial? It is not defined. Degree of a 0 polynomial is not defined. It is represented by 0. S square plus 2xy minus y. This is polynomial with 2 variables. Now we concentrate. In this section we concentrate polynomial with only 1 variable. There are polynomial with 2 variables, 3 variables, 4 variables, etc. Our concentration is polynomial with only 1 variable. That means x square plus 2x minus 1 or x square minus 1 or t square minus 2. These are all polynomial with 1 variables. Polynomials are denoted by the variable they use in the expressions. For example, shall I? Polynomials are denoted by the name of the variable they use in the expression. Suppose the polynomial x square plus 2x minus 1. What's the variable used here? X. So this polynomial is denoted as px is equal to. That means instead of px you can write this one. Or instead of this one you can write px. It doesn't mean that px is equal to. It doesn't mean that. Then suppose another t square minus t plus 1. How can we represent it? Oh, you can use pt or qt. This is denoted by this one. Okay. Then another polynomial y square minus 2y. How can you represent? Yes, gy. So polynomials are denoted by the name of the variable they use in the expressions. This is not a polynomial equation. This is not the polynomial equation. Polynomial equations are this one. Suppose is equal to 0. This is a polynomial equation. This is a polynomial equation. Which of the following are polynomial with one variable? If it is not polynomial with one variable, you have to mention the reason also. Whether this is polynomial with one variable? Yes. This is polynomial with one variable. Exponents of all variables are whole numbers. That's right. Okay. Whether this y square plus. How can we represent this polynomial? Px. Okay, right. Px is equal to y square plus root 2. Yes. Yes, this is only root 2. No variable is there. Root 2. What's the degree here? 2. What's the degree here? Degree of the polynomial? 2. Quadratic polynomial. This is also a polynomial. This one. This is an expression. Whether this is a polynomial with one variable? No. Exactly. Why? Here the power of the t is not a whole number. T raised to 1 by 2. Root 2 means root t means t raised to 1 by 2. It is not a whole number. So this is not a polynomial. That's the reason. Yes, this is enough. Here one of the term is root t. Root t is equal to t raised to 1 by 2, which is not a whole number. So this is not a polynomial. Polynomials are algebraic expressions in which exponents of all variables are whole numbers. This is not a whole number. So why do we write root 2 after this variable? Yes, in order to avoid the confusion. Sometimes they write as root 2t, then some students may get doubt that this root will include this t also. So in order to avoid that confusion, root 2 is right after the variable. Okay. This one. Yes, this is not a polynomial with one variable. Why the reason? Yes, 2 by y. Here the coefficient of y is y raised to minus 1. 2 by y means 2 into y raised to minus 1. It is not a whole number. So this is not a variable. This one. This is an algebraic expression. Whether this is a polynomial with one variable? No. How many variables are there? This is polynomial with 3 variables. What's our questions? We have to point out polynomial with one variable. So MCQ type questions may ask very simple questions. You have to write the coefficient of s square. What's the coefficient of s square? 1. Yes, minus 1. 5 by 2. Root 2. What is the degree of this polynomial? 3. 2.